In previous chapter, we understood what Java is capable of, and now it's time to look behind the curtain. Let's understand how Java actually runs the code under the hood and the tools that make it all possible. In this chapter, we'll get a clear picture of how Java runs behind the scenes, from writing your code to seeing it come alive on your screen. We'll start with JVM, that is the Java Virtual Machine. This is the engine that runs your code and makes it truly platform independent. Then we'll move on to JRE, that is the Java Runtime Environment, which includes everything you need to run any Java application. Next, we'll have a look at the JDK, that is the Java Development Toolkit. This is the complete toolbox developers use to write, compile, and run Java programs. This just won't be in theory. We'll also get hands-on experience by installing the JDK, using Java compiler to convert the Java code to bytecode, and then actually running your Java program through command line interface, that is CMD on Windows. So let's get into it, shall we? Let's start with the engine that makes Java run, that is the Java Virtual Machine. This is what allows Java's philosophy of writing once and running anywhere. It runs your compiled bytecode on any device, whether it's Windows, Mac, or Linux, by converting it to machine-specific code at runtime. Beyond just running code, the JVM handles a lot behind scenes. Not that you have to worry about it, it's just good to have knowledge. It manages memory using structures like the heap and the stack. It clears unused memory with automatic garbage collection. It keeps your execution secure, verifying bytecode and using sandboxing and access control mechanisms to protect your system. And to boost the performance, the just-in-time compiler, or the JIT, it compiles frequently used code into native instructions while your program is running. Inside JVM, there are three core components, that is the class loader, which loads the class into the memory. Then we have the runtime data areas, which manage memories for your program. And then we have the execution engine, which actually runs your code. Understanding JVM helps you write portable, secure, and efficient programs in Java, no matter where they are going to run. And now that you understand the JVM, let's move on to the next step and talk about the Java Runtime Environment, that is the JRE. This is the engine that brings Java applications to life on any operating system. The JVM in itself is the abstract machine which is responsible for running Java code, but JRE is something which you are going to install on the operating system wherever you need it. At its core, the JRE contains the JVM. That is, JVM is part of the JRE, which runs your Java bytecode on any platform. It also includes a set of pre-built libraries, ready-made tools for file operations, networking, GUIs, and data structures. And it bundles the supporting resources which are needed to make sure your applications run smoothly end-to-end. You will find JRE used in places like banking software, enterprise applications, Java-based desktop tools, especially on end-user machines. Now let's quickly go through the key components of the JRE. First, we have the JVM itself, which executes the bytecode, manages memory, and handles garbage collection. Then comes the class libraries, offering reusable functions so the developers don't have to write all of the code from scratch. And finally, we have the class loader, which dynamically loads and verifies classes while your program runs. The JRE doesn't include any development tools like compilers or debuggers. So if you're planning to write and build Java code, the JDK is what you need. That is the Java Development Kit, the JDK. The JDK, or the Java Development Kit, is your complete toolbox for Java development. It gives you everything required to write, compile, run, and package your Java applications. It includes everything that comes with JRE, that is the JVM, the standard Java libraries, and the entire runtime environment. So you can run Java programs without any extra setup needed. But what makes JDK special are its set of the developer tools. All of your Java code is going to have an extension of .java. Javac is the compiler that turns your Java code into the bytecode, which has an extension of .class. Java is the launcher that runs your compiled Java programs. Javadoc is used to generate clean documentation from your code comments. JDB is a simple debugger for inspecting and fixing issues. And jar is a tool to package your entire application into a jar file, which can run on any operating system. And it's easy to distribute as well. It also comes bundled with Java standard libraries, giving you powerful tools while working with data structures, file, input, output, networking, multi-threading, and much more right out of the box. So to sum it up, JRE is something which is going to help you run Java programs, whereas JDK gives you the complete set of tools which are needed to actually start writing Java programs. And now that you have seen these three components, here's a simple way to remember it. JVM is the abstract engine that runs Java code. JRE is the actual software which you're going to install, which helps you run Java programs, and JDK is a complete toolkit for developing Java programs. So let's walk through the very first step for any Java developer, that is installing and configuring the JDK. For that, we can head to its official Oracle website, and here you can see we have different versions you can go with. So the most recent one is JDK 24. Let's just go with the most latest version, and here you see you have different versions for Linux, Mac OS and Windows. I'm going to go with Windows, and here x64 installer. So you just click here. It's going to download that installer on your system, and once it's done downloading, you can just open it. The setup process is fairly straightforward. The wizard should guide you. All you do is just click next. This is where you can customize the location. I'm going to go with the default one, and next, and then you close. And now comes an important part. We need to set environment variables. To do that, we just go to this PC and properties, and here we have advanced system settings. You go here, and here we have the option to set environment variables. We just go here. Here we need to create a new variable called Java Home, and the variable value would be the path of the installation. By default, it is going to be in program files and Java and JDK and bin. So you need this complete path. You just Control C, and here you just paste it, and OK. Now that we have set Java Home, we also need to add that path here in this path variable. You just edit here, add a new environment variable here, and paste the path here, and remove the bin, and OK. This allows your system to access Java from any terminal window, and that should be OK now, and click OK. Now you can open command prompt, and to verify that Java installation is successful, you just enter command java space dash version, and you see we have Java 24 installed successfully. Also, we can check Java C version. This is the Java compiler version. So you see both Java and Java C, they are installed successfully on our system. With JDK installed, the next step as a developer would be to write a simple program and compile code and see it in action. For that, we'll be using the Java C compiler command. Java C tool is the Java compiler which comes included with JDK. It takes your .java file written in plain Java code and converts it into .class file that is filled with bytecode. This is the code which your machine actually understands. And this is the key to Java's cross-platform magic. The .class file can run on any machine with a JVM, no matter the operating system. One of the biggest advantage of using Java C is that it catches error early in your programs. It won't compile your code until and unless all of the errors in your code are resolved. Even if you miss a semicolon, or you make a typo error, or you make a logical error, Java C will detect it, and it will let you know that this is the place where the error is and you need to correct it before the Java program actually gets compiled. To see that in action, let's create a simple Java program. To do that, you just create a new text file and you open it. And this is where we are going to write the most simplest and the most basic form of a Java program, the Hello World program. What this does is it basically defines a class with Hello World. It has this public static void main method, and this is the print statement which is going to print Hello World onto the console where we are going to run this. And the way we save this program is just copy the class name, because you have to make sure that the name of your Java code is the same name as the class, and you go to the file save as and just write the class name here and save it as .java, and under the save as type you change it to all files and save. So we have our Java program ready to go. You can delete the text file which we created earlier since we have this Java code now. In the address bar you can just type cmd. This will open command prompt in that same location, and here you can write Java C. That is the command to compile Java code, and then we write the hello world.java. And carefully observe what happens here. Since we don't see any error here, the compilation process is successful, and you see it has created this .class file. And if you open this with any notepad, you see it's going to have this kind of gibberish code. This is the bytecode, which is understandable by the machine itself, so you don't have to worry about it. This is what you are going to work on. Behind the scenes, the compilation process includes three main steps: the parsing, where your code is read and broken into structure; the semantic analysis, where the logic and correctness is checked; and the bytecode generation, where the final .class file is generated. So we have this hello world.class file. If there is any error in your code, the compilation process stops then and there itself, and it gives out a clear error message indicating where the error is, that is in which line the error is present. Using javac not only turns your code into bytecode, but it also improves quality of your code, avoids runtime surprises, and ensures that your application runs anywhere on a JVM. So if I move this .class to any operating system which has a compatible JVM installed, it's going to run on that system without any issue. Now that we have compiled our Java code, it's time to actually run this Java code using the Java command. Let's have a look at how Java command works and what happens during the process of execution. Once we have compiled this code, running it is pretty simple. You again just go to command prompt, and we have hello world.class. So we are good to go ahead to run this, and to do that we just use Java space hello world. We don't need to enter any extension here. You just need the name of the file, and you enter. You see hello world as the output. Now sometimes you may still run into different errors here, so you may need to check your code based on that error you see. That's pretty much it. That's how easy it is to run a simple Java program. And once you have done it a couple of times, it kind of becomes second nature. And that brings us to the end of this chapter. Let's quickly recap everything we have covered about the Java ecosystem. We started by exploring Java Virtual Machine, the engine that runs Java bytecode and makes Java platform independent. Then we learned about the JRE. This is the actual application which you need to install on system, which makes your Java program run. And then we discussed JDK. This is the complete set of tools which a developer needs to write, compile, and run and package Java applications. And as a practical guide through, we went through the process of installing JDK on our system, in this case Windows operating system. And then we wrote a simple Java program and went through the process of how Java compilation works and how to run that compiled Java program. In next chapter, we are going to discuss some of the popular integrated development environments, that is IDEs for Java. And we are going to install a couple of them to make this process of learning Java much more comfortable for you. And yeah, that's about this chapter. I'm Venkatesh Mudalia. Till I see you again in the next one. Cheers.